Today we're going to look at some types of questions you might get and some useful shortcuts with them. So here we've got an example question. We've got x follows a binomial distribution with 10 trials and the probability of success is 0.4. We want the probability that x is less than or equal to 8. So that means we're going to do all of the values from 0 up to and including 8, but of course that's quite a lot to do. So we can use 1 minus the probability that x is greater than 8. So that would be the probability that x equals 9 and the probability that x equals 10, which would expand to this. And then we can get our final answer. So this type of question is where we're using the fact that the sums of the probabilities equal 1. You may have even already practiced some of those on the last exercise. Next example, we've got a factory that produces boxes of batteries. For each battery, the probability that it is faulty is 0.05. We want the maximum number of batteries in a box for which the probability of having no faulty batteries is greater than 80%. So in this case, we don't know how many trials are happening. We're finding out what the largest number of batteries, that would be our number of trials, could be in that box, so that we don't get a chance, so that the chance of having no faulty batteries always stays above 80%. So we can let x be the number of faulty batteries in a box. Then x would follow a binomial distribution where n is our number of trials we don't know yet, but our probability of success is 0.05. So the probability that it's faulty, that we find a faulty battery. So the probability of x equals 0 has to exceed 80%, so it has to be greater than 0.8. So if we put our calculation in, it would look like this. Now n choose 0 and 0.05 to the power of 0 will be 1. So we're just left with 0.95 to the power of n has to be greater than 0.8. So we can do a bit of trial and error of what n could be. So we can try out n is 3, try out n is 4. That's both of them are staying above 0.8. We can try out n is 5. That one then takes us below 0.8. So n has to be 4. Now that is the way that you can be expected to do it, but there is a little faster way of doing it if you want to use logs. This is not necessary at AS level, but if you can learn this way, it makes this a little bit faster. You don't have to do the trial and error part. So once you get that inequality, you can take log of both sides. Then that power to n can be brought down and multiplied by the log 0.5. And then divide through by log 0.5. Now notice the inequality has changed directions. That's because log 0.95 is a negative number, and if you're dividing through by a negative number on the inequality, it changes direction, so you have to be very careful here. Just type log 0.95 into your calculator to check whether you're dividing by a negative or not. Okay, so moving on, we then get that to be n has to be less than 4.35, so n equals 4. Now this type of question is an inverse one, where we're not told the number of trials, we're told the probability, and we have to work backwards from that to find the number of trials. Okay, next one. We've got bags of mixed lollies. The favourites are gummy bears. The bag contains 10 lollies, and for each lolly the chance that it's a gummy bear is 0.3. We want the probability that Koya gets more than 2 gummy bears in his bag of lollies. So that'll look like this. I'll move through this part quite quickly because it's actually the second part that's the interesting bit. So working out that it's greater than or equal to 2 would be 1 minus the chance that it's less than or equal to 2, which gives us this probability. Right, next part. Part B, Koya buys 5 bags. What's the probability that exactly 3 of the bags contain more than 2 gummy bears? Now bear in mind part A was finding out the probability that you get more than 2 gummy bears in the bag of lollies. So now we have a new distribution. Y is the number of bags with more than 2 gummy bears. So y follows a binomial distribution with 5 trials because we've got 5 bags, and the chance of getting a bag with more than 2 gummy bears is what we just worked out in the previous part. So now we want the probability that you get exactly 3 bags with more than 2 gummy bears. So that will be that calculation there. And there's our final answer. So this is a type of question where you're using one probability to then go on and make a new distribution from that probability. And these are a fairly common type of question for the exam. You need to make sure you've got your head around it.